All right, class, welcome back to Natural Intelligence, the blueprint for AI, where we talk about getting our understanding of our biological operating system or our processing unit, the human brain, before we jump into artificial intelligence. I think it's imperative that we understand how our brain works and, more importantly, how we learn before we start to pile in on the artificial side. We're continuing the course today with lesson number 4, where we'll talk about parallel processing, which is dual coding in multimodal models for AI. Your brain processes images and words on two separate channels, and it does this in parallel, and your AI does it as well. Now, quick recap in what we talked about last class. We talked about how working memory holds 4 chunks of your brain's hardest processing constraint, right? So we learned in the previous lesson with the working memory, the bottleneck lesson about those 4 chunks of information that your brain can hold. If you exceed the limit and information overwrites or decays within 15 to 30 seconds. So you only got 15 to 30 seconds before that information gets dumped, before it gets actually passed on through to the working memory. We also learned that an LLM, or large language models, context window is its working memory. Both face the same bottleneck on the biological side as well as the synthetic side with the AI models. And a way for us to hack the bottleneck, we learned that you could use a chunking strategy. And we'll talk about chunking strategies a little bit more when we get to pre-processing large language models, fine-tuning them, and also RAG, retrieval augmented generation techniques. But we'll talk about chunking in a little bit later. But as it pertains to the bottleneck, chunking compresses inputs to fit the fixed capacity of our brains. You also built a chunking protocol template if you were an architect, and if you're on the system, if you're on the builder path, you built a system prompt for the bottleneck to hack that. Key insights that we talked about in the last class: chunking compresses information to fit the bottleneck, but what if you could actually open up a second lane entirely? And that's what we're going to talk about today with the dual channel or dual processing mechanism. So let's walk through the biological hardware here. Now, the mission again is to double our bandwidth, right? This is very important as we're trying to ingest especially complex technical information. We want to squeeze as much of our brain capacity and bandwidth out as possible. And we'll do that using dual coding, which is like this process of visual and verbal information on parallel channels. So just imagine you are watching this video, you're listening to me speak. You may be looking at or see some diagrams or some infographics that come up on the screen. Well, you're processing information in multiple channels there. You're not only just listening, you're also seeing visual cues that will help your brain digest the information a little bit easier. Now, the mechanism itself was brought about by Alan Paivio, and this is called the dual coding theory in 1971. This is where the brain encodes information through 2 independent channels, right? And you have a verbal system and a visual system. You'll hear this spoken about a lot in the academic circles in education, where you have a verbal or visual learner. And then you also have folks that are more tactile learners as well. They need something physically to work with their hands, and they're better that way. But actually what they're doing, they're visualizing things through the ability to use their hands, but they're still visualizing things with just physical contact. Now, the problem is that most learning today, although that is changing a little bit, especially with the advent of AI models that can generate images and videos, but traditionally most learning is text only, which is not great because it's just a single lane highway, and you're completely leaving half of your cognitive bandwidth unused. You're basically using half of your brain or half of your capacity. So every text only tutorial essentially wastes a channel. So what we'll be doing throughout the course here especially when we get into some of the AI topics that are a little bit more dense, that have a lot more um, technical chops to them, so to speak. We will be using a lot of these dual channel mechanisms in order to get that information through to you, to override some of that biological hardware. Now, just remember, again, we're trying to double or increase our bandwidth. And so having these two channels, we essentially get 2 times the recall when both channels are engaged. We can recall from our verbal cues or verbal channel, and we can also recall from what we saw, right? We've all sort of had these experiences where we would study for something or we would learn something, and we could maybe be more quick to identify or recall that information if we visualized it, if we saw maybe a certain graphic or an image or maybe some type of visual movement, video movement, and that allowed us or animate, I should say, animation. That allowed us to remember the information, recall the information a lot easier than verbal. And then some folks are just the opposite, where they can hear, they can, their ears or their ability to hear information was a lot easier for them to digest whatever they were learning at the time. So everybody's a little bit different. The key is not to be one way or the other. The key is to maximize both to the best of your ability, but also be able to identify which one you're strongest on in your natural state. So what is dual coding exactly, and how does it work? So again, we've already talked about the verbal channel. Now, the verbal channel, again, is going to involve lots of words, language, sequential logic, what you see here on the screen, a lot of words and logic on the screen. And then the visual channel is going to have images and diagrams, spatial layouts. You'll have channels that operate independently in parallel. They'll have a cross connections functionality that essentially forms a stronger memory trace because of these cross connections. So think of it again as creating some connective tissue here between the two channels, making it again hard or sticky in your brain. And then you have location, whereas the left hemisphere or left brained, as some folks would say, is your verbal hemisphere, and then the distributed bilateral hemisphere is the visual. Now, the highway analogy here, just think about it. Text-only learning is just a simple one-lane road, whereas with dual coding, you're going to have a second lane, all right, a second toll lane that opens up for you to be able to allow traffic to flow through more easily. The same bottleneck per lane. So again, we still cannot bypass that 4-chunk limit that we have. We've just essentially doubled the capacity for the 4 chunks on each of those lanes that we have within our biological limits. But the total throughput doubles. And so the key here is channels must be complementary, not redundant as well. So keep that in mind. You don't want to have competing information or channels competing at the same time. Right? You want to make sure they're complementary, not redundant, to better, again, create those neural pathways. Now, the bridge here to our AI, let's look at the bridge in the comparison between the two. On the human side or biological side, we have the dual coding, but on the AI side, we have the multimodal models, right? And many of us know these as some of the models that allow us to generate not just only text, which was what we were essentially able to do with GPT-2 and GPT-3, but as time passed, over the past 3 or 4 years, we've gotten these very advanced models that now allow us to use text and vision encoders. There's also encoding fused embeddings for richer context. We'll talk about what embeddings are, how information gets encoded in a large language model or an AI system. We'll talk more about that. On the human side, right, again, we still have those verbal and visual channels available to us, and the encoding is through dual traces of the 2 different channels, allow for, again, stronger recall, increased bandwidth, more than one lane learning. Again, you're still limited to the bottleneck of the 4 chunks, but essentially you've got more throughput here. Now, the strategy on the human side is that diagrams and narration in parallel. So just again, imagine, as you'll see in some of the lectures that I give, or lessons that I'll show you and walk you guys through, we'll be using diagrams, infographics, especially when we're talking about system design and architecture, right? So you'll see graphics and diagrams, but I'll also be talking you through or walking you through the diagram. So you're also getting both the verbal and the visual information all at once in parallel. On the AI side, a strategy could be something like an image in the text prompt in parallel. So imagine again, you have that context window. You may write a text prompt, but you may also add an image reference to that prompt to help you out a little bit. Now, the weaknesses on the human side is that redundant channels can cause overload. So again, you want to avoid redundancy as much as possible. And then on the AI side, the weakness, as with most AI strategies and mechanisms, it's the hallucination on visual details. So, this is where you get those fingers that look weird when you're generating humans, or when maybe their teeth or their eyes are just not quite syncing up or look right. It's um, that kind of telltale sign that you have that something's generated by AI. I'm not generated by AI, by the way, but if I am, I wouldn't tell you anyway. So there's that. Now, the axiom is a multimodal AI processes text in images on separate encoders, right? So essentially, it's two separate channels and the same architecture as your brain's dual coding system, right? So both achieve higher fidelity by processing complementary channels in parallel. Right? Now, how do we get past this? How do we bypass this particular dual channel or dual coding mechanism that our brains have? Well, we have these strategies. We have 4 different strategies we can use. Number 1 is going to be to visualize the abstract. So again, we'll talk about converting text concepts into diagrams, flowcharts, or mind maps. Right? It's a neural network architecture becomes a visual graph, not just a paragraph. And again, you'll see this as we get into some of the more technical, more complex material, right? I'll be using a lot of visual aids, especially for my newcomers and my beginners to technology and AI. I'm not just going to throw a bunch of code or a bunch of words or text at you, because you'll need some visualizations to just visualize that abstract of the particular concept. And then number 2 is going to be narrate the visual. So when studying diagrams, write verbal explanations. If you see a system architecture, describe each component in your own words. So this is almost like you're taking your own notes on the information. And that's actually another way that you can be developing the neural pathway, is with your writing as you're listening and watching. Right? You may be getting a trifecta there of channels as you are writing physically, or maybe you're typing as well. And then number 3 is going to be sketching before your code. So before writing any implementation, draw the data flow. So this is where, again, as engineers and developers, we'll do wireframes, we'll do actual mock-ups of a flow of an architecture, flow charts and whatnot, to show just the logic flow of a particular system. And so this is whiteboarding the architecture, right? It's definitely part of the interviews for software engineering and other development positions that we're all very familiar with. Now, the visual plan activates a separate memory trace from the code itself, right? So again, this helps if you can visualize it. It makes it a lot easier to take those visual elements and break them down into individual coding objects. And then finally, number 4, you use AI as a visual engine. So again, this is kind of using AI as your friend here, prompting multimodal AI to generate diagrams, concept maps, and visual explanations. Turn every text block into a visual and verbal pair. And this is really a game changer when it comes to learning, simply because for forever, however many years, we've all been sort of at the realm of our instructors or our lecturers or our, whomever we may be at the front of the classroom. And it was up to them to explain the information to us in a way that we could understand. But now we have, this amazing tutor that we can, again, break down a concept and describe the concept in a way that makes it more digestible for us, using our relevance, using our own context with inside of that prompt. And so this again creates a better learning experience for everyone overall. So definitely something I'll be encouraging as we walk through future courses. And if you haven't done this yet, don't worry. It's quite simple. And once you do it once or twice, you're pretty hooked on that's the new way of learning for you. Now, the build objective for this particular lesson is going to be to we're going to be creating a text to visual translation guide. So text to video or text to image, right? I'll leave that up to you. If you want to do video, you absolutely could, right? But this is going to be a repeatable system for converting single channel text into dual coded visual and verbal learning material. So again, just imagine you're looking at a very large we'll just say a research paper or a novel or a book or anything that is just primarily text. Maybe it's a long article. How do you take that information source and turn it from just single channel, just a blob of text, a big wall of text? How do you turn that over into something that's dual coded with visual materials? So my architects, you guys are going to be designing a manual text to visual translation guide that any learner can use to convert text heavy materials into dual coded resources with diagrams, mind maps, and visual summaries. So you'll be attacking it from that aspect. For my builders, you'll be doing the same thing, but you all will be using a system prompt that will instruct a multimodal AI to automatically generate those visual representations for any text-based learning materials. Now let's go over some of the requirements for each of the tasks for each identity, respectively. So your translation guide must include scanning, must be able to identify text-heavy concepts that would benefit from visualization. You need to be able to classify with this particular template or a file that you're creating, match each concept to a visual type, flowchart, mind map, diagram, matrix, timeline. Right? And you're not restricted to these, right? You can think of any visual artifact or visual object that works best for you, right? Think about, put yourself in the shoes as the learner, as you're learning material, what type of visual aid would be best for you. Then you're going to translate, create the visual with a complementary, not redundant verbal caption. Again, we're not trying to be redundant here. We want something that's complementary because, again, if it's redundant, it's kind of laying another lane on top of another lane. You're not getting the expansion that the benefit or which is the maximum benefit of expanding that capacity by having dual channels or dual lanes. Right? So we want to make sure it's complementary, not redundant. Then we're going to pair everything up, ensure every visual has a verbal anchor and every key text has a visual partner. And then finally, verify, test recall using only the visual, then only the verbal. Both paths should work. So if you're able to recall or just remember the information, be able to recall the information on demand by using either one of those channels, you know you've got a good product or text to visual guide in your hand. Nice little example here that you could do talking about how an API works. We're going to be talking about APIs during our AI course, application programming interface. And that's going to be just the text, but then that text is going to become a flow chart where we have a client, and then we have a request, and we got a server, and we have a response, and then we have a client, right? So we have this flow of information essentially being transported from client to server. You'll be able to see that visually, not just the abstract reading it. You can connect it to the actual visual flow of the information. The client sends a request, the server processes it and returns a response, and that's the verbal anchor there. All right. So you should be able to recall that particular example using either one, the actual flow chart or visual aid of the flow chart of the client request and server response, right? Or being able to recall using, again, just the language here of the client sends a request and the server processes it and returns a response. Okay. Now for my builders, you guys are doing the system prompt, right, to instruct AI to help you guys. So accept any text-based learning material as input. Again, it could be a research or white paper. It could be an article that you read. It could be a transcript from a YouTube channel. So just think about something that's text based or that could be converted over to text. And that's going to be where you start. Then you need to identify the top 4 concepts that need visual representation. Now, you maybe can do this by just skimming through that text based learning material, or maybe you prompt the AI to help you do that for you. I'll leave that up to you, builders. And then you'll generate a visual description or diagram specification for each concept. Then you'll pair each visual with a complementary, not redundant again, avoiding redundancies as much as possible here, verbal summary, output in a structured format, visual spec, and verbal anchor per the concept. And then finally, include a retrieval test section with visual only and verbal only recall prompts. So you're going to test your understanding or test the actual accuracy of your prompt for your AI instructions. Okay. Now, the stack you'll be using is combining this with lesson 3, the chunking protocol, and lesson 2, the high salience prompt for the full pipeline. So you'll be learning about all 3 of those: the gatekeeper, the chunking protocol from the bottleneck, and then today's lesson, which is again the dual channel. All right. Now, that should be it today. Let's go over the takeaways here. Again, just a quick recap. Your brain has 2 independent processing channels, verbal and visual. Right? This is dual coding theory from Alan Paivio in 1971. That's where this emerged from. Number 2, engaging both channels nearly doubles recall compared to text-only learning. Number 3, multimodal AI mirrors dual coding. So that's our bridge from the human to the AI. Is we have dual coding as humans, and AIs have multimodal models. This separates separate encoders for text and images on the AI side fused into shared context. And then channels must be complementary, not redundant. The redundancy effect kills the advantage, right? If you're essentially, again, not getting the full usage of that additional bandwidth if you're being redundant. And then finally, number 5, stack your tools, the high salience input or prompt that you use in previous lessons, and also the chunking prompt from our last lesson. And then today's prompt, the text to visual. So these should be stacking. You should be building on these, with each class that we have, and with each build or project that you build or complete for the assignments. So you should be, by the time we get through all of these axioms, should have a pretty nice system developed. Now, the next class, we will be talking about the knowledge graph or schemas, essentially a scaffolding for holding information for us and structuring it, and how that relates to our bridge, our AI bridge, which are vector embeddings and RAG, or retrieval augmented generation. So again, you'll start to hear these terms. I know for my beginners, the terms are a little bit new, but you'll hear them over and over again. And as you start to hear them a little bit today, and in our early lessons in the natural intelligence course, when we get over to the artificial intelligence course, then you can start to make some connections there a little bit, because it won't be the first time you've heard a phrase. So yeah, that's all I got for today, guys. See you next class. Class number 5 is on its way. Thank you so much again for your time. Thank you for allowing me to serve you, and always keep learning. But for now, class is dismissed. Peace.